All right, this is your lesson on Rolle's theorem and the mean value theorem, two very important theorems that we will be using quite a bit on the AP test. So first we're going to start with Rolle's theorem. Rolle's theorem says, let f be continuous on the closed interval, closed with the brackets a to b, and differentiable on the open interval from a to b. So some graph that is going to be continuous. That means you can draw it without lifting your pencil. Okay, so let's say that I have some number here that's A, and some point here that's B, and we have some graph. Let's see, we're going from here to here. All right, so that they are on the y's of these 2 points are equal to each other. So f of a and f of b are the same. So some function, if I plug a in, I get the same value. And I plug b in, I get the same value. All right. And there's some continuous graph. Let's say it looks something like that. Okay. So if f, this is f, if f is continuous on the closed interval and differentiable, so it's smooth, no pointy things on here, right? And between a and b, and if they are on the same y value, where f of a and f of b are the same, then there's at least one point in between a and b where the slope has to be 0. Does that make sense? That somewhere we're going to be able to draw a line where the slope is going to be 0. Somewhere between there it has to have a slope of 0. Or shall we say the derivative is 0. And we're going to call this point here C. Okay? So there has to be some place between A and B, at least one, where the slope is 0. Okay, let me redraw this for you. Let's say that this graph looks a little different. Let's erase all of this here. All right, let's say my graph now looks like, this. Are there any horizontal tangent lines? How many are there? I see 3. I see one here. I see one here. I see one here. So that means there's at least one. So there's one here. C1, the first one. And then there's another one, C2 and C3. Okay? So no matter how I connect them between there's going to be at least one point between A and B where it has to have a horizontal slope or a 0 slope. That makes sense? Even if I connect them directly across like that, there's going to be many, many, many points in between A and B that have a slope of 0, almost infinite number of points. All right, so that's Rolle's theorem. Okay, so let's see what a problem might look like. Here's my first example. Find the two intercepts of f of x is equal to x squared minus 3x plus 2, and show that f prime of x is equal to 0 at some point between the two x-intercepts. Right, so there are two x-intercepts. If we solve this, factor it, we get x minus 2, x minus 1, and if I set that equal to 0, to find the x-intercepts, right, x-intercepts when y is equal to 0, I get first one is going to be 2, x is equal to 2, and then the second one is going to be x is equal to 1. So those are my 2 points that are x-intercepts. To solving that. Okay, there's nothing to do with the derivatives yet. So the graph looks like this. All right, we found 2 points. We found one at 1, 0, one at 2, 0. And then we want to prove that in between these two x-intercepts, there has to be a place where there has to be a horizontal tangent line where the derivative is equal to 0. So let me take the derivative of this. Let's see, if we take the derivative of f of x, I get 2x minus 3. If I want the derivative to equal to 0, we make 2x minus 3 is equal to 0 from here. Right? We took the derivative and made it equal to 0. We solve this. The 2x is equal to 3, and x is equal to 3 over 2. And the 3 over 2 is right here, 1.5. 3 over 2 is 1.5. At 1.5, it's going to have a horizontal tangent line. Okay, that's a nice illustration of. Okay, here's the second example, illustrating Rolle's theorem. Let f of x equal x to the 4th minus 2x squared. Find all values of c in an interval between -2 and 2. This is not ordered pair. This is an interval. So both of these are x's. X is between -2 and 2, such that the derivative of f at c is equal to 0. Okay, so we're going to first see if it satisfies our Rolle's theorem. Rolle's theorem says if f is continuous, okay, this is a fourth order polynomial function. So you know it looks like a W. Remember in pre-calculus we learned that this is the left and right hand behavior is going up and some wiggly thing in the middle. Okay, so it's continuous. You can draw this without lifting your pencil. And it's differentiable, so it's smooth all the way between there. I'll even show you what that graph looks like. Okay, that's the graph, and this has all the answers on it, but we're going to still work it through. So this is what this would look like. It's continuous. It's differentiable. There's no pointy things on it. Okay, so now I'm going to... Okay, we're going to go ahead and find the derivative of f. So that'll be 4x cubed minus 4x. I'm going to factor out of 4x, and we get x squared minus 1. We set that equal to 0, right? Set the derivative equal to 0. We get a 0, and then we get a plus or minus 1. So you see that there's a 0 at -1, get a 0 at There's a 0 at 0 and another 0 at positive 1. So our answer is going to be, there are 3 zeros at these numbers. Or there are going to be 3 C's. Now these are going to be my C's. Right? These are the C values. Okay? All right. I'm going to talk about the mean value theorem. The mean value theorem just uses the Rolle's theorem, and it proves that there has to be some slope between these 2 points, A and B, right? You have f of A is this value right here, and f of B is this value. And all right, let's see if we can do one here. We have a given function f of x is equal to 5 minus 4 over x. Find all values of c on the open interval between 1 and 4 such that the derivative of c is equal to the same slope as between these 2 points. This is just the rise over run between these 2 points, and I want the same slope as that. So first we need to find this. So we're going to f of 4. F of 4 is 4. This is f of 4, right? And this is the 4, and this f of 1. So they happen to be the same because this line right here, this x is equal to y. So we're going to find the slope, which is this part, and that'll be 4 minus 1 over 4 minus 1 is equal to 1. So we want to find some point on here where the derivative is equal to 1. So we're going to find the derivative now of that. So derivative of 5 is 0. And then we have this going on here, which is this. Okay. And we take the derivative of this, we get positive 4x, right? Positive 4x to the negative 2. So that would be the derivative. Okay, move the x back into the denominator. And we want that to equal 1 because the slope is 1. So this gives you the instantaneous slope, and we want it to be right there. So we're going to multiply both sides by x squared. So we get 4 is equal, we get 4 is equal to x squared. Take the square root of both sides, and we get x is equal to 2 and negative 2. But only this one is between my interval. This one's not in my interval, so we don't have to worry about that one. Now we want to find this point right here, which happens to be 2. And how do we get the 3? We get the 3 by putting this back to where we can find y. So this has to go back in here. Okay, so 4 divided by 2 is 2. 5 minus 2 is 3. That's how you get this point right there. Okay. All right. That's Rolle's theorem, means value theorem. And what I would like for you to do for me is to do these two problems here. They're on page 176 out of your book, or you can just write them down from this page right here, 11 and 12, and 39 and 40. So bring that with you tomorrow. Those are just some examples that we had gone through. Thank you very much.